All right, we're going to work on our chapter review for Chapter 4, Part 1. We will be covering lessons 5.5, 4.1, 4.7. Again, remember, in your review, it tells you where to look in your notes. And again, that should be the primary resource that you use when studying for the test. Make sure that you read through those notes, highlight any questions that you might have, and talk with the teacher. The first couple questions, I want to make sure that you understand. The question says, number 1, how do you find the biggest angle of a triangle if you only know the side numbers? And what I want you to remember is that the biggest angle is always opposite the longest side. Remember, the biggest angle is opposite the longest side. The converse of that is also true. How do you find the shortest side of a triangle if you only know the angle numbers? And remember, the shortest angle, or the shortest side, is always opposite the smallest angle. Again, the shortest side is always opposite the smallest angle. We're going to use that on this first chunk of questions right here. Specifically, we're going to talk about question number 5. Question number 5 is an angle problem, and you do need to find the shortest side and the longest side of the triangle. If you notice in question number 5, we don't know all of the angles, and so you must know all angles before making any decisions. In this triangle, we would take 58 and add it to 60, and that's going to give you 118. Then we would take 180 minus 118, and we find out that this third angle is 62 degrees. Now if we look at the angles, we see that 58 is my smallest angle, and remember the opposite side is the one that does not touch it. On the outside here, RQ does not touch angle P. Those two are opposite. Then we find the biggest angle, which happens to be our 62, and we identify the opposite side, which again does not touch the green angle, and PQ is my longest side. Then we talked about the sides of a triangle and if it will even make a triangle. Remember that if you have one side, the other two sides must be more than that. Otherwise, the two sides will fall down and never touch each other. So, for example, in question 12, when they give you the two sides, all you need to do is add the two numbers and subtract the two numbers, and that will help you find the range that the third side can be. When you add 30 plus 14, you get 44. When you subtract 14 from 30, 30 minus 14, you get 16. These two numbers right here are the smallest and the largest that the third side can be. So we say that that third side is between 16 and 44. If you want to write that as a sentence, you would write third side between 16 feet and 44 feet. Notice that the math sentence is a little shorter. When you get to triangle problems that have pictures, you're basically setting up the same problem, except the third side is this unknown 2x plus 5. I recommend that you go to your notes 5.5 and look. There are some more examples there that I think are very helpful. But remember, all we need to do is focus on the two numbers given. We add the two numbers and we subtract the two numbers. And we know that the 2x plus 5 must be between 2 and 20. And then from there we have an inequality that we can solve, and we will find the range of the variable x for that third side, which must be between 2 and 20. We also had problems in our 5.5 notes where we had to draw a triangle according to specifications given to us. The most important thing, I think, is organizing your information so that everybody's triangle will look the same. We need to sketch a triangle that has sides that are 32, 48, and 61, with the shortest side on the bottom and angles of 31, 52, and 97 degrees with the largest angle on the left. I think one easy way to do this if you're struggling is to organize your information from small to big or big to small. I'm going to go small to big, 32, 48, and 61 for the sides. And then we would do the angles in the same order, 31 degrees, 52 degrees, and 97 degrees. And remember, these numbers need to be opposite of each other. So, according to what it says, it asks for the shortest side to be on the bottom and the largest angle on the left. So the left side is over here. The shortest side is on the bottom. Finishing out our triangle. And then we just fill in our numbers. Shortest side on the bottom, that would be the 32. And I know opposite the 32 up here has to be 31 degrees. The largest angle is on the left, so 97 degrees goes here. And opposite that 97 degrees is the longest side, 61. And then the other side, the other angle, the 52 degrees, has to go with this side of 48. Noticing that the angles go in the corners and the side lengths go on the lines. I just want to make a quick sketch of 23, just so that we get the right diagram. It says that it has to have the shortest side on the right and the largest angle on the top. So when we draw that, the largest angle will be at the top and the shortest side will be on the right. This being the right side, so this will be your shortest side over there, and up here is your largest angle. Again, organizing your information, small to large, putting the opposites across from each other. On page 3, we move on to lesson 4.1, where we talk about classifying angles. We do that by the words equilateral, isosceles, scalene. Remember, equilateral has 3 equal sides, isosceles 2 equal sides, scalene has 0 equal sides. And the angles obtuse, right, and acute. Obtuse angles are angles that are greater than 90 degrees. Right angles are equal to 90 degrees, and acute angles are less than 90 degrees. So make sure that you go by the markings. And again, you want to make sure that you do your calculations of angles so that you know how many degrees everything is. For example, in this first diagram, we have 2 angles that are 60 and 45 for a grand total of 105. 180 minus 105 is equal to 75. Now that we know that, we can make a good decision about the measures of the angles. The The last problems that I'm going to do for you are in this section, and that is a combination of lessons 4.1 and 4.7, taking everything we know about triangles and calculating values of x. Questions ask you to solve the following triangles and find the value of x. State whether the angles are interior or exterior angles, whether the triangle is isosceles or equilateral. Those are the main things that we're going to think about. For question 40, I notice that this 2x is outside the triangle, and that is where you add these two angles together. So I'm going to note that that's an exterior angle problem, and I know that when I add 30 plus 20, that should equal 2x. 30 and 20 is 50 equals 2x. Dividing by 2, x equals 25. When I move on to question 42, I notice that all of the angles are inside the triangle. So I note that they're all interior angles, and when that is true, they should all add up to 180 degrees. So I'm going to take the 52 and the x plus 12 and the 90 degrees and equal that to 180. Don't forget about the 90. Adding up the numbers that I have there, 52 plus 12 plus 90 gives me a grand total of 142 equals to 180. Take away the 142, and I get x to be 38 degrees. X to be 38. And then on the last question, I read the diagram and I notice that I have two angles that are equal to each other. And that means that two of the sides have to be equal to each other. So in this case, the 20 is actually extra information. All I need to know is that 28 is equal to 9x minus 8. Because this is an isosceles triangle. When I solve this, I get x equals 4. Good luck on the back page. If you have problems, talk to your teacher tomorrow in class.